which is at rest always like to maintain its state of rest. An object which is in motion like to maintain its state of motion till an external force acting on it. An object at rest can change its state to motion by an external force. Like that, an object in motion can change its state to rest by an external force like friction. Any object would like to continue to be in its state of rest or state of motion. The inherent property of the object to resist any changes in its state of rest or state of uniform motion unless it is influenced by an external unbalanced force is known as inertia. Only less force is needed to stop a moving boat, but large force is needed to stop a moving ship. More mass, more inertia. So, inertia depends on the mass of the object. This inertia can be classified into three: inertia of rest, inertia of motion, and inertia of direction. Place a cord over the open end of the glass tumbler. Place a coin on the top of the cord. Flick the cord horizontally. What will happen? Cord moves away, but coin drops straight into the glass tumbler. Why coin is not moving along with the cord? Both cord and coin are in the state of rest. With the external force, cord changes its state, but coin can't able to change its state immediately. The resistance of the body to change its state of rest is called inertia of rest. A person standing in a bus falls backward when the bus suddenly starts moving in forward. When the bus started suddenly from the rest, the lower part of the leg sticks with the bus, so it goes forward with the motion of the bus, while the upper part tries to remain in rest due to inertia of rest. When a moving bus stops suddenly, passengers standing inside the bus tends to fall forward. This is because the lower part of the leg comes to rest with the bus, while the upper part tends to continue its motion due to inertia of motion. The resistance of the body to change its state of motion is called inertia of motion. The long jumper runs some distance before jumping because this will help him to jump longer and higher distance due to the inertia of motion. When a stone tied to one end of a thread is moving rapidly in a circular path, and if the thread suddenly breaks, then the stone flies off along the tangent of the circle. The inability of the stone not able to continue in circular path is because of the inertia of direction. The resistance of the body to change its direction of motion is called inertia of direction. When a vehicle makes a turn towards right side, the passenger sitting inside the bus turns towards left side. This is because of the inertia of direction.
Do you remember the Newton's first law of motion? It says that an object will continue to do what it's doing unless acted upon by an unbalanced force or some net force. Now the important question is, what happens when there is net force acting on an object? That's precisely what the second law of motion will discuss. Do you remember understanding the first law of motion with a simple diagram? If the forces are balanced, the acceleration will be zero. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced, only if the net force is zero. Now let's try to create a similar diagram for the second case. If the forces are unbalanced, then there will be acceleration. We saw that in the previous video. And now we come to the interesting part. Let me ask you a question and I'm sure you can answer it. On which two factors do you think the acceleration will depend on? I want you to tax your brain a bit. Let me repeat my question. On which two factors do you think will the acceleration depend on? Okay, let's say there's an object on a table. You apply a net force of 10 units on it. And then you apply a net force of 20 units on it. In which case do you think the acceleration will be more? Of course, the one in which the force was more. So we can say that one of the things the acceleration depends on is net force. If it's more, then more will be the acceleration. If it's less, then lesser will be the acceleration. Acceleration depends directly on the net force. Come on, now I want you to think about the second quantity the acceleration will depend on. Let's say there are two objects on the table. One has a mass of 3 kilograms and the other has a mass of 5 kilograms. Now, if you apply net force of 10 units to each of them, which one do you think will accelerate more? Surely it's the 3 kg one because it has lesser mass. Lesser the mass, more the acceleration. And more the mass, lesser the acceleration. Hence, we can say that acceleration depends inversely on the object's mass. If you understand this concept well, then understanding the second law of motion will be very easy. Mathematically, it can be written like this. In simple terms, the acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. That's the second law. Or as more people understand it, like this. The net force is the product of mass and acceleration. With this, can you tell me the units of force? That should be easy. The standard unit of mass is kilograms, and that of acceleration is meters per second squared. So the unit of force is kilograms times meters per second squared. And this is what we call as Newton. 1 Newton is 1 kilogram times meters per second squared. So if the mass of the object is 10 kilograms and the acceleration is 10 meters per second squared, then the force will equal 100 newtons. We can say that 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second squared.